Okay, good morning, good afternoon, viewers, dear viewers, friends and colleagues. So this is a second session where we'll continue with a presentation by Dr. Rand Elshereef. So as you probably recall, we left at the types of data collecting in biomanufacturing and by what, meaning by different sensors, inline, online, and also at-line instrumentation and offline, meaning that it's done in the lab, which not mentioned, but it also includes logistics. People need to take it, to package it, transfer it, get the approvals from management, and then bring it to the lab. And then the same situation happens on the lab side when it's done. It's used for testing, scheduled for testing, done, analyzed, and then discussed, and then basically approved by managers. And then only after the people from the process see it back and can analyze the data. So it's also logistics that's behind the scenes here. So Rand, the floor is yours. In the interest of time, let's continue. It's a lot to see and a lot to hear. And okay, thank you.
Okay. Thank you, Marina. Thanks a lot. So now, okay, we explained about the overview, or we had an overview about the complexity of the data structure collected from biomanufacturing, the types of data. And then now let's go to, this is a summary, by the way. So now here we are focusing on the fermenter. So you can see that here we have the fermenter, or the type of data that we are collected online. We have here inline data represented by air, O2 profile, CO2 profile, the carbon dioxide profiles, oxygen profile, the pressure, the viscosity, the stirrer speeds. All of these are captured in online. We have also from online sampling the assay instruments like GC, MS, NMR, flow cytometry, and it captures different aspects of the cell culture during the growth. And also we have the biomass, glucose, all the metabolites profiles, such as like lactate, and that are produced during the fermentation. We have offline data. So you can see how complicated this data, very large amount of data. Now, here, when we see here this data, you can notice that this data is heterogeneous. So we have different places. It's heterogeneous. We have discrete data, we have continuous data, we have categorical data, and we have data collected at different frequencies. Even for online data or inline data, we have data collected at different frequencies. Some measurements are collected every minute. Some measurements are collected every like 2 minutes or every 3 minutes. So different frequencies. How can you bring together all of this information with lots of varieties, and combine them in a data prepared for analysis? A huge amount of data with many complexities. So, and also we have data collected different time stamps. We have batches collected. You cannot guarantee that each batch every day will start at the same hour, the same minutes, the same seconds. Never. I mean, it is very complicated. Now, what can we do here to turn data into a value using analytics? We collect the data from different sources, from MES, LIMS, and PyHistorian. Okay, now we go to the second step, which is data preparation for analysis, making sure that these data are collected in a suitable format for analysis. Otherwise, you cannot start the third step, which is statistics and learning. Because if you have data that are not clean and poorly prepared, then you will not be able to get information, right? From information on how to improve your process. And then the third step is interactive charts. Of course, you need, after you extract insight from the analysis, you need to communicate these results into the upper management and subject matter experts. And those subject matter experts, they don't have like a full background about data science. You need to make sure that you communicate the most important information for the subject matter expert that are important for how to improve their processes, how to optimize the processes, what variables are and process conditions are affecting the product quality. So translating this technical language into a language in terms of that have business value, where you can achieve the business value. And then we deliver the actions, and of course we use this data to the insights extracted from data to increase efficiency, the quality, increasing the speed, reducing the costs. Those are the business value that we get from extracting the data from biomanufacturing. Now, if we go to the next step, now let's go deeply into each step. Data collection from different sources. I mentioned that about we have raw materials. We do measurements on these materials. And we mentioned before about MES, which is the manufacturing execution system, which is it relate each raw material going to each batch to the batch ID number, right? So here we have measurements collected for raw materials. We have offline data. We have online data. And we have inline and so on, inline data and so on. And also we have data that are collected, product quality data. How we can put this data into those sources into a suitable format for analysis. So here we go to the next step. This is a representation on how to perform data preparation for analysis. So all data related to raw materials will go into a block, which is a Z block, where rows represents lots and columns represent the measurements. So here we have lot 1, lot 2, raw materials lot 3, 4, 5. Okay, and all the columns will be the measurements, the type of measurements acquired for each lot. Okay,
For raw
and then
materials.
for raw materials, exactly. So we have all historical data. We call it historical data. And here we have block for offline data will go to a one block, which is X1 block. Online data will go to another X block, which is X2 block. And again, each row represents measurements, process measurements acquired for this particular lot. Okay. Now we go to the quality. Quality is the final product quality attributes acquired after, for example, performing the final product quality acquired from the at the end of the biomanufacturing process, which is important in terms of we try to understand how raw materials and process variables are affecting the final product quality. I mean the cause and effect relationship, because understanding the cause and effect relationship will help us to optimize the process, will help us to achieve the optimal conditions. What combinations of raw materials and process conditions that will result in acceptable product quality attribute. That's why it's important to arrange the data in terms of ZXY format. Y is the response, X are the measurements or the effects. So all we have lots, execution system, and order now execution system, ID number that represents a quantity that need to be produced, all raw materials related to this lot and process variables, and the quality attribute related to that are represented by one row of data. And this applies to lot 2, 3, 4, 5,
Each
and
lot
whatever.
has it. Each lot has it. And then you take it
Exactly.
to analyze it as one, basically, right? As a
Yes,
together. It makes
together.
sense.
Exactly. Even the continuous data are getting unfolded. So even the continuous data, when we say online data, this will be represented in one vector in lot, which is start of measurements at time 0, measurements after 2 hours, 3 hours, 5 hours, until the end. It will be a vector. It will be a row in the data. So that we will be able to distinguish between different lots. Okay, so this is a broad overview. We prepare the data for analysis. Now let's go to the next step, analysis and modeling. So imagine all of these thousand and thousand of measurements and data from different instruments and different unit operations. Okay, we apply machine learning in order to extract the most important information, summarize all this information into a low dimensional space. The low dimensional space is just like we have here T1 versus T2, where we call T1 is a summary variable, index, summary index. T2 is a summary index again. And some analogy is that how can we analyze the economy of a country is we have a kind of or the performance of different companies is we have a kind of economical index or stock
Oh,
index that represent the performance of thousands and thousands of companies in the country. Here, the same applies. We have a score plot, and you can see two clusters, and each dot, it's just like represents lot, one lot,
that is a
and you
lot.
can see that two clusters. Why we have two clusters? We can see that, oh, okay, group one are produced under particular conditions. Group two are produced under different conditions. Now, this results in two clusters. Now, by looking at the raw data of thousand and thousand variables, you will not be able to understand this. You will spend like lots of time, lots of manual effort by looking at thousands of charts, represent thousands of measurements, and it's impossible to figure out that particular difference between different lots using by analyzing the historical data. So this is the beauty of machine learning is that it's bring this large amount of data into a low dimensional space where we can identify patterns, similarity between different products, trends, timely shifts, and we will see how final product quality is affected by raw materials and process conditions.
No, this is
Now, if we go to
this
the
is
next step,
critical, yes, because
yeah,
quality is basically like your final say. So if you basically relate back to raw materials to process variables and link it, that's where, like you mentioned, it's economical value. It's when you can translate all this effort into make sense. Is it economically beneficial, or the process has to be further optimized? So this is critical, and thank you for insights. So let's go
exactly.
forward. Yes.
Yeah, and here we go to the next step. For example, a request comes from from the manufacturing to the data scientist. Hey guys, we noticed that there is a trend in the product quality attributes. You see the trend here with the circles. There is an observed trend with respect to product quality attributes produced for different lots. Okay, and you see that there is an increasing trend for this product quality. Now we're trying to understand what is going on with the process. So instead of going through each variable at a time. We have thousands of variables, and we have a large biomanufacturing process from raw materials until fermentation, downstream processing until the packaging. And instead of doing that, we do drill down analysis, okay? And using a drill down analysis, we identify like two clusters. One cluster which has low product quality, the other cluster is high product quality, and we perform drill down analysis. And using the drill down analysis, we come up with a chart. And this chart is showing that a drop in the carbon dioxide evolution during fermentation, a drop in the oxygen is causing such low product quality. So this is from the analysis, and of course, the subject matter expert will derive a hypothesis in order to try to understand. For example, try to understand, come up with a hypothesis, try to explain what's going on during the fermentation. So it's not the drill down analysis will explain to you the most likely contributing factors towards what's going on. But it's not like blindly relying on the data analysis. We need to explain. We need to have an explanation, scientific explanation of what's going on. So, but this is how we can do a drill down analysis. And instead of investigating all those 1,000 variables, we can investigate like a bunch of 10 or 15 variables that most likely relating to what's contributing to poor quality attributes. Now, this is one application. Another application is that you can see that we apply online monitoring. So imagine you can see that here there is a plot of upper limit and lower limit. The upper limit and lower limit represents the performance of the process during the time evolution here. And anything outside the upper limit and lower limit will be outside or performance that is outside the specification here. The upper limit and lower limit are derived from the data analysis. Okay, it's like similar to setting up a statistical process control chart with plus or minus 3 standard deviation for one profile. But this profile that is between the green one, it summarizes all the 1,000 profile that exist in during fermentation. Okay, so it's like a summary plot, an index which represents the performance of the process. Anything within the upper limit and lower limit is considered to be acceptable. It means that the batch that we are running are similar to all the good batches that we run in the past 2 years or 3 years.
It's within the
Now, this will help
specification
us.
or trending,
Yeah,
right? Yeah. Mhm.
exactly. So here we can see that there is a batch in the black color that is outside or below the lower limit. This means that something is wrong with that batch from time zero until the end of the batch, in terms of time zero, in terms of days, until like it's outside, totally outside. Now, there is a tool that is called contribution plot. Here we can identify what factors are contributing to this batch being outside the acceptable limits. And here you can see, for example, you can see here that this variable, which is highlighted, the two variables highlighted in orange, are contributing to that particular batch being outside the acceptable region. Okay. Now this will help us also. So here another batch evolution. Here you see that all batches that are within the upper limit and lower limit are acceptable. In the second plot, we can see that there is a batch deviation that start after 25. Okay, so here will help us to capture any faults or errors or leakage. Once we capture this, we can implement a corrective action. Again, there is a third example that shows different batches. There is one batch that where a deviation starts at around like 35 hour. Another batch where we have a deviation that start at around 120 hour. So there are different example, and this is called
Yeah.
online monitoring and real-time monitoring. So now we have all of this example of the application. This is just like a summary. Again, we collect data, we prepare data for analysis to make sure that the statistics and learning that are reliable. Okay. And after that, we have also interactive charts in order to communicate the business value to subject matter experts and to communicate what important conditions that need to be improved in order to optimize the product quality attributes, or, for example, do a troubleshooting during in real-time monitoring, right? So I think thank you very much, and let me know if you have any questions.
Thank you so much. I think it's good you have email here. I think it's important for the viewers. They can follow up if they want to have contact with you, and also in case they want consultation or support. That's wonderful. I think if we go back to previous slide, or at least for me again, one learning point is basically two learning points. Is one is investigation. When you mentioned that you can scrutinize the data and basically highlight the aspects either from the process variables or maybe from raw materials, depends, that really potentially can be issue and result in the outlier or the batch which is not acceptable. It's beyond either above or below the specification. So this saves a lot of time because I'm coming from analytical lab, and where I was fitting most of my life is this offline testing when you get samples and test. And of course, many tests I learned it's dear to my heart, and you worry about one test, but when you look at within the the myriads of data that you put together, it is really a drop in a huge ocean, and it's important to see how it fits and whether it's a key method to visualize it or maybe completely not. It's something else we need to focus on. So that saves huge amount of time about the investigation, which is usually very heavy in terms of both time and resources and people's time actually who spend on it. And second time, I think we're all in many industries, but in pharmaceuticals, I think it's a very it's a highlight how you can relate to the cost. Can you decrease the cost? How you can decrease the cost? How you can demonstrate the value? This is really the questions, daily questions for the all departments, not just analytical or the process development department, but still many departments. And this data that you presented, the approaches, it gives the visualization where you can zoom in and where you can highlight to justify why your recommendations may be valuable for the management to make certain decisions. So justify these decisions, or at least give all information you have in a packaged form, so it's easier to, I think, analyze or discuss and make decisions. So I think this is great. And anything else you would like to add? We still have maybe a minute or two, and then we'll wrap up.
Yeah, I think I totally agree with you, Marina. You mentioned about the cost aspect,
Yeah.
and also just I want to add, yeah, about the cost. For example, all companies they look into reducing the costs by increasing the batch to batch consistency.
True. Yeah.
Reducing the variability between batches in terms of product quality attributes. So if the product quality has a wide distribution, they are aiming by applying real-time monitoring and kind of advanced process analytic technology into controlling the process such that they will be able to reduce variability, lot-to-lot variability, and therefore reducing the variability. So we have what average and a build shape that has a kind of narrow distribution. So this is what they are aiming, because this is related. So instead of having an upper limit and lower limit that are wide, they want to reduce the upper limit and lower limit, and this will result in more consistency in terms of the lot-to-lot variation of product quality attributes. And this is, of course, related to the process. If we can monitor the process very well, we will be able to control the process and respond to any kind of deviation as quickly as possible. And also responding to any situation as quickly as being a proactive will help us to save as much batches as we can, not to lose batches, right? Because if we run a batch and we are not able to detect leakage or see, so then we are losing like millions of dollars, right?
That's absolutely right. Yes, it's
Yeah.
efficiency,
Yeah.
but also why? It's also to prevent losses. That's the toughest questions,
Exactly.
probably, right?
Yeah.
To prevent losses. Yeah, yeah. So
Yeah.
definitely that's key. But I think also what you mentioned is narrowing distribution. I'm coming from many years I was doing differential scanning calorimetry. So one of the curves which gives you narrow distribution is the melting of collagen. It's really a narrow curve, almost perfect, and it shoots very high. So it takes huge energy, but it takes, very a small span of temperatures to unfold. And so I think that resembles it. You have to really have like spike and to keep it as narrow as possible so that it's, getting, like you said, controls the process better.
Control
And
the process. Yeah.
yes, gives a chance to detect issues faster. Thank you so much. I really appreciate your time. Thank you for coming to the channel. And with that, we'll stop here. And as you've seen to the viewers, please, so if as you've seen on the slides, you can scroll them. There is a contact information for Dr. Ram. So if you need to contact him for consultation, here it is. So reach out. Okay, we'll see you next time. Thank you so much. And we'll stop.